All right, a couple problems that I wanted you to, first of all, try, but then we'll talk about. The first one is this one, where Jesse examines the two figures. It says at the right, but really they're below. But she wants to figure out if they're similar or not. So it says decide with your team, but you're going to have to try this on your own. But I want you to think about, okay, is there enough information here to determine if the shapes are similar? And then if you had to explain that, how would you explain that? So pause the video, think about this, and then come back and we'll see what you might have come up with. All right, so when you check this, probably the first thing you thought about is, well, what's the linear scale factor? If I look at this side, it's 7. This side's 21, so our linear scale factor was 3. Then you might look at, okay, well, what's the ratio between the areas? Or in other words, what did I multiply the first one by in order to get the second area? Well, if I look from 40 to 360, I multiply by 9. And then I check and see, okay, does the relationship work? Well, we said the linear scale factor, if it's 3, then the ratio of the area should be 3 squared, or in other words, 9. So at first glance, it looks like, yeah, this really is enough information to determine if they're similar or not. Here's the problem, though. They only gave us one side to work with, and they didn't really talk about the angles. And we've done enough this year to not rely on our eyes. We need a little more information. So technically on this, there's not enough information to make the decision on whether they're similar or not. Let me give you another example. I could maybe have 2 triangles. Maybe I gave you a triangle that had a side of 4 here, and I gave you another triangle that had a side of 8 here. And I looked at the areas, and the area, maybe I'd find out was 10 here, and the area is 40 here. So at first glance, this is another one where if I look at the scale factor, the linear scale factor was 2. If I look at the areas, I multiplied by 2 squared, or 4. So it kind of fits my bill, but we also know that, wait a second, these two figures are not similar because they don't have the same shape. Okay, so we can't rely on our eyes. We need a little bit more information. They'd have to tell me about the angles being the same, or they would have had to give me some more sides to check. All right, one more question here. Your teacher enlarged the figure at the right, which is really below, so that the area of the similar shape is 900 square centimeters. We want to know, well, what's the perimeter of the enlarged figure? All right, so they're saying, I've got this figure right now. It has an area of 100 square centimeters. We want to find out, well, what's the perimeter of the enlarged figure that we're going to create? So we're creating this new figure, and this new figure has an area of 900 square centimeters. Or in other words, we multiply by 9. Well, in order to figure out the new perimeter, we're going to have to think about what's our linear scale factor. So that's really our first order of business here. What is the linear scale factor? All right, well, if I multiply by 9 to find the areas, we're going to backtrack now to figure out the linear scale factor. So I know if the scale factor is given to me, I can square it in order to find the area ratio. So if I'm going in reverse, that means I'm going to square root it. Or in other words, my linear scale factor should be 3. What am I going to do with that? Well, they said they wanted to know the perimeter. So that means I've got to take each of those sides and I need to multiply them by 3. So my new figure, I'm going to have, instead of 8, I'm going to have 24. Instead of 4, I'm going to have 12, 15, 30, 39, and 12. So if I were to add all those up, I would see what my new scale factor, or sorry, my new perimeter is. So if I add all those up, I get 132. All right, so that would be one option there, and that was centimeters. Something else, though, I might have done for this one. Let's go back to the original figure. Well, if I go back to the original figure where we had 8 and 4 and 5, 10, 13, and 4. And I found the perimeter of that original figure. Let's see what that perimeter would be if I added those together. So I've got 12, 17, 27, 50. I got 54 right now. Well, I already know that the new perimeter was 132. I had that wrong. Sorry, that was 44, not 54. But I already know that the new perimeter is 132. But if I didn't know that, what I can do, because perimeter deals with side lengths, and side lengths really refers to the linear scale factor, I could have taken that 44 and multiplied by the linear scale factor. And when you do that, I get that perimeter that we already discovered. So you had two different ways to do this when you could have either taken the perimeter and multiplied by 3, or you could take each side, multiply by 3, and then found the perimeter. And that's kind of what we're going to be working on, is kind of going back and forth with different situations. Like this one, maybe I'm given the areas, and we find out the ratio there, and we backtrack to the linear scale factor. Maybe I start with the linear scale factor, and then I have to square it and look at the areas. At some point in time on down the line, we'll throw in volumes and see how volumes fit into all of this. But that relationship that's going on here is an important one. So it's one that we'll have to remember and we'll use quite a bit.